Um, Hi, we are again. So today we are going to solve this third exercise. Okay, knowing that this one and this one, all these 7 marks exercise is already solved. If you want to see, you can just go to other videos in the same channel. You'll find all of them there solved. So today we are going to solve this one. So for this one, it is the question number 3 and line C. Okay, what does it say? It says that we have how can I say this one? We have, this is the initial volume. Okay, the initial volume, it means that it is in the first state. The initial volume, it is V1 of 0.9 kilogram of acetylene gas was 0.75 meter cube. So V1 is 0.75 meter cube and M is 0.9 kg. The temperature of 15 degrees Celsius. So first temperature, first volume, mass. Then we have A pressure, okay, and the pressure of 1 bar. First, this is also the first pressure. So this is the first state of the gas itself. Then they gave something very important. After adiabatic compression, the volume is reduced to 0.28. Now it is final volume, okay? That was 0.75, now it's 0.28. And the pressure was found to be 4 bar. Now it is the final pressure. They asked to calculate gas constant R, molecular mass M, if this is the universal gas constant. Then they ask us to find what is the ratio of specific heat. Ratio of specific heat, it is nothing more or less than what we call the gamma. Okay, it is Cp upon Cv. Then find Cp, find Cv, and find change in internal energy. Okay, yeah, in a nutshell, okay, in a very conclusion, just space of conclusion. So this will be our data. Okay, they say that we have mass of 0.9 kg and we have volume. First volume is this 1.75 meter cube. P1 is 1 bar, 10 to the power 5 Pascal. We have to convert. And we have V2 is 0.28 meter cube. This V2 is got when we have adiabatic compression. After adiabatic compression, it was like this in state 1, then it went to state 2. So we can call this a process. It's adiabatic process. And this is adiabatic compression. Why? Because V1 is greater than V2, as you can see here. And you can see here also by the data. V1 is 0.75 and V2 is 0.28. Now, P1 here is 1 bar, okay? So it's compression, okay? Pressure here is lower and pressure here is higher. So as we can see, P1 is lower, P2 is higher. Nice, and they gave us universal constant of gases. Wow, this is fine. So now, what do we have to do? We have to find R, constant of gas. We have to find M, okay? We have to find Cp upon Cv, that is gamma. And then okay, Cp upon Cv, that is, they call it like ratio of specific heats, okay? Cp upon Cv, gamma. Then they ask us Cp and Cv and delta U. What is, this is internal energy, okay? Change in internal energy. Now let us calculate first what is R, okay? So see, to calculate what is R, we can use this relation here. PV is equal to mRT. This is nothing more or less than Clapeyron gas constant. Okay, Clapeyron gas, Clapeyron equation of perfect gases. Okay, so this is this. Now to find our R here, we have to do what? We have to consider a state in which we have P, V, and T. The first state, we have PV and D. We have PV and D. It is like the first state here, state 1. So just substitute. Here we got P1, V1, M, R, and T1. Now here you can calculate directly what is R. R will be P1, V1 upon T1 and M. R will be, substitute all the values here, 1 times 10 to the power 5 times V, 0.75. Then T1, what is T1? T1 is 288. Okay, here I guess we didn't write, but they gave us T1, it is 15 degrees Celsius. T1, it is 288 Kelvin. They gave us in the data. You can see here, T1, this part over here, 15 degrees Celsius. Okay, I just forgot. Now, time, what is mass? Mass is 0.9. After calculating all of this, you get R is equal to 289 point something like 35. Okay, 35. This is R in joule per kg. Okay, joule per kg Kelvin. Okay, now that we have found what is R, the next is to find what is M. So secondly, R is found, so R, okay, now we have found, sorry, 2. Now we have to find what is M. Now we know that universal constant of gas, it is equal to characteristic gas constant times M. This is molecular mass. It is the molecular mass of this one. So to find the molecular mass here, what we have to do is just to divide all by R. Divide it all by R. You get this one, R0 by R. So substitute all the values, 8314.3 upon 289.35. Here you got M equal to 28 point something like 0.27, if I'm not mistaken, maybe or something like this. 10.7, no, 0.7, 28.7. Okay, this will be, okay, your mass. Okay, so now that we have found this our mass, okay, let me just see if it is mass. Okay, this is mass. We found for molecular mass. Okay, this is the molecular mass. Now from here we can say that, yeah, this gas is almost nitrogen. Okay, this gas is nitrogen almost. Okay, now third, okay, in the third we have to find what is ratio of specific gas. So see here they say that this is a adiabatic comprehension. Okay, to find this specific gas, or this guy, okay, that is Cp upon Cv, okay, that is gamma. To find gamma, we have to put or computerize for the two states that we have. The first state is P1 V1 gamma raised to gamma is equal to P2 V2 raised to gamma 2. So here we just find this one. Okay, we can just put this one there. We can just put this one, P1 upon P2 is equal to V2 upon V1, and this is gamma. Now apply ln here and here, both sides. What we'll get? We get ln of P1 upon P2 is equal to lambda, gamma ln of V2 upon V1. Okay, now we have just to find what is gamma. So gamma will be ln of P1 upon P2 divided by ln of V2 upon V1. So find this one. This will be equal to 1.4 and 1.407, something like that. So we can round it. Okay, gamma will be 1.4. We can round it to this one. Now we have found this the relation between Cp upon Cv. Okay, ratio. Now let us go for the fourth asking that they are sending for us. They ask them the first question. They said what to find what is CP and what is CV. So we know by notation that CP upon CP minus CV is equal to R. And here we know also if we divide all this expression by CV, okay, divide it all by C, okay, CV here, and divide it all by CV, what you will get? You get CP upon CV, and here you got 1, and here it will be R upon CV directly, R upon CV. So here it will be CV times this CP upon CV is gamma minus 1 is equal to R. Okay, from here, what you get? From here you can, okay, directly find what is your CV. So CV will be R upon gamma minus 1. CV, I know R. What is R? 289. Okay, if I'm not mistaken. Okay, just go down. Okay, 289.35 upon 1.4 minus 1. This will be 289.35 upon 0.4. Just go for this and you will get 289.35, okay, divided all by 0.4. Okay, this one CV will be 723.4 almost. Okay, and this will be in joule. Okay, joule, we have the same unity of this one, joule, kg, Kelvin. Okay, as this R, this will be the same, joule, Kelvin, kg, Kelvin. Okay, now we know CV. So now that we know CV, directly we can just find, okay, what is CP? CP minus CV is R. So we know CV, we know R. So CP will be R plus CV, and this will be R, 289.35 plus, okay, 723.30. Yeah, we can just play 38. I just rounded this for okay, but actually the real result is this one. So I will just use the two last digit after the comma here. So if you find this guy, it will be directly plus 289.35. Okay, 289.35. Nice. And this will be almost 1012.7. Okay, something like this. Yeah, 0.7. Okay, 0.7. This will be joule, kg, Kelvin. Yep. Okay, now that we have found, we know CP is 1012.7 joule per Kelvin, kg Kelvin. CV is 723.30, okay, 37.5 or something like this, joule, kg, Kelvin. Now it's done. Now let us jump for the fourth one. Okay, we are about to the fifth one. So in the fifth exercise, they ask us what is delta U. So delta U, we know it is M CV delta T. Okay, to find delta U, we know M, we know CV, and we need only what is the second delta. So we know M, we know CV, so it will be M CV T2 minus T1. Here, as we know, we have only T1, but we do not have T2. What do we need to do to find T2? Now, it is adiabatic compression, so T V lambda minus 1 is equal to constant. So here you can find T1, okay, V1 lambda minus 1 is equal to T2 V2 lambda minus 1. Okay, now from here we know everything here, we just do not know T2. So send this T2 there. This will be V1 upon V2, this is T1, lambda minus 1 will be equal to T2. So just substitute the values there and you will find what will be T2. T1 here, just put T1. What is T1? T1 is 288 times V1 upon V2. V1, we know it is 0.75 and 0.28. Okay, here will be 1.4 minus 1 and just find it all, T2. Now let me just computerize this one. This will be 288 times, okay, 0.75 divided by 0.28, okay, to the power 0.4. Now after computerizing this one, you get this value, okay. Okay, you get this value. This one is 427.12 almost in Kelvin. This value will be in Kelvin as this one is in Kelvin. So now here what you have to know, just substitute this value in there. Okay, just put this one, it will be M 0.9 times CV. CV is 723.4 almost, and here T2 is, we know T2 now, 427.12 minus 288. Multiply all this value and you will get this one, minus 288. Now multiplied by 0.9 in 723.375. Okay, okay, this MCV will be given in, okay, delta U will be almost 9,000 and 574, okay, 574.8, okay, 574.8. so this will be in Joule. This will be in Joule. So okay, if we want Joule, we can just make it in kilojoule. Okay, this will be this point 564 kilojoule. Yes, we can like that. So it's okay, we are done. Thank you very much. Hope you may enjoy this one. Okay.